Hello class, this is part 1 on the lesson secants, tangents, and angle measures. Theorem 9-11 says that if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. By secant, we mean a line or a segment that intersects a circle at exactly 2 points. So think of a chord being part of a secant. Okay, so we have that this secant FH, it intersects the tangent FG at the point of tangency, which would be at F. So the theorem says that each of the angles that are formed, and here I am showing one, that the relationship between that angle and the arc that it intercepts would be half, just like the inscribed angles. So here I'll be able to make the conclusion that the measure of angle F should be equal to half the measure of arc from F all the way over to B. It looks like it is a major arc, so I'll go ahead and use 3 letters to name it. So from F goes through C and stops at B. Regardless of whether it is a major or a minor arc, it will be half the measure of that arc. Here's an example. We have to determine the measure of angle ABC. Angle ABC is there. So because we have secant line, so we have a line that intersects the circle at exactly 2 points, and then we have a line that appears to be tangent. So we're going to apply the theorem that says that the angle formed, in this case angle ABC, then that should be equal to half the measure of the arc it intercepts. So from A all the way over to B. Now that appears to be a major arc, so let's go ahead and use 3 letters. So A goes through D and stops at B. Now the measure of arc from A through D that stops at B is going to be equal to 360 minus the arc AB, which is 102. Okay, so that is going to be equal to 258 degrees. So that means that the measure of angle ABC will be half of that. So half of 258. And this will be equal to 129 degrees for the measure of that angle ABC. Next we have theorem 9-12. It says that if two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. First of all, let's remember that anytime two lines intersect, we will always end up with 4 different angles. So that's what we have here, 1, 2, 3, and 4 different angles. So this theorem says that if you do have 2 secant lines that intersect in the interior, okay, so point V is definitely not the center of the circle, and it is definitely not on the circumference, so it is inside the circle. Then the measure of an angle formed, so meaning out of the 4, choose 1. Let's say that I choose this angle over here. So if I wanted to know the measure of angle FVE, then the theorem says that it is related to 1/2 the sum of the measures of the arcs intercepted by the angle. So this angle here intercepts this arc over here, and the arc intercepted by its vertical angle as well, so back here. So this measure of this angle would be equal to 1/2 the sum of the measure of arc FE and the measure of arc DH. Okay, so that's if I wanted to identify that measure. So what if instead I chose this angle over here? The measure of angle EV VH. Then that's related to 1/2 the sum of the measure of the arcs intercepted by that angle. So in that case, it would be this arc over here. So the measure of arc EH plus the arc intercepted by its vertical angle. So this one over here. So the measure of arc FD. And because we do have vertical angles, so as long as we can figure out one of those two, then we should be able to figure out the other ones. But then this would be the relationship between those arcs intercepted and the measure of the angle. Here's an example to apply that theorem. We need to determine the measure of angle 1 and the measure of angle 2 based on this figure. So the measure of angle 1 is going to be equal to half the sum of two arcs. Okay, so I need to figure out what those two arcs are. So angle 1 is over here, this angle, and that angle intercepts arc BC. So I need the measure of arc BC, and I also need the measure of the arc the vertical angle intercepts. So meaning that I need this arc over here. So I need the measure of arc AD. Okay, so that means that the measure of angle 1 is then going to be half the measure of BC, 30, plus the measure of arc AD, 20. So I need half of 50. So that means that the measure of angle 1 is then 25. In order to go ahead and figure out the measure of angle 2, I don't really need to apply the theorem, given that angle 1 and angle 2 are linear pair. So the measure of angle 1 plus the measure of angle 2 is going to be equal to 180 degrees. Don't forget all of those relationships. So the measure of angle 2 is then going to be equal to 180 minus 25. So that's going to be equal to 155. So those would be the two measures.